All right. So first one, we're doing simplifyings first. It's recording right now. Oh, I'm picking book problems. No, because I'm writing them I wrote them here, because we're going to show the work here after I give you guys a minute to try it. First one is sine times cotangent. Yes, you would get the identity sheet. I would have mine out to look at while I'm doing this to simulate what the test would be like. And I will give you the identity sheet so you don't get to use your own, but you do get to use your old homework, so. And then you'll turn in anything you used on the test with the test. Just FYI tomorrow. Okay? So the old homeworks that you used for the test, you need to turn in with the test. Everybody's okay with that? Yeah. I'm going to pick things that I think are equivalently difficult of what I would ask you to do there. Hopefully this first one has got nobody too scared. All right. So in general, if you're not sure what to do, the best strategy is to write everything in terms of sine and cosine. One, the sine is already there. Cotangent is the same thing as cosine over sine. And hopefully at this point you go, aha! Cosine x and you're done. Why is there an equal sign there? Let's say we have let's try to pick something else. Let's say we have this one. How about this one? Sine squared plus tan squared plus cosine squared all over secant squared. Those are all additions. I did not mean to then. I wrote down what I meant. Howdy. I have two for you. Megan. Doesn't look like it. Elena. Want me to keep it to her? Sure.
Bye.
See you, Mr. Coolwood. See you, Connor.
Bye.
I think Abby's
Oh,
cute.
interesting. Does Abby think he's cute? Okay. So, hopefully you notice something rather useful right away. Sine plus cosine, or sine squared plus cosine squared is? Good. And then 1 plus tangent squared, does that look familiar? What do you mean by leave the plus sign? Well, is tangent squared being multiplied to sine squared plus cosine squared? How did you factor it out when there's nothing in common? Oh dear. Oh dear. Oh dear. So far nothing has been excruciatingly long, right? That's really what I aimed for, was things that required like 1 to 3 steps if you went about it in a reasonable manner. So I tried to pick things that were pretty doable. Let's do, oh dear, I don't know. Well, I'm trying to pick another one that looks...
No, I know. I'm thinking
I think you must be kidding. So this one's maybe a little bit more tricky, but can still be done rather quickly if you think about it in a good manner. Okay. So what I did first is I noticed that since each of these numerators was going to be the same, I was just going to leave them be at first, but I rewrote the denominators just in terms of sines and cosines. And that seemed like a good idea to me because when I simplified these complex fractions, I got tan x over 1 times sine squared over 1, and then tan x over 1 times cosine squared over 1. And I now have no denominator in my fraction. So I have just an expression. Everybody okay with that? I notice in that expression each term has a tangent in it. If I factor that off, I have tan times sine squared plus cosine squared, which is just tangent. Yes. Go ahead to the bathroom. When do you know? You could have turned into sines and cosines also. You would have eventually gotten just one tangent left, doing the same kind of factoring that I had. Because you would have, at this step, you would have ended up with like sine cubed x over cosine x plus cosine cubed x, or I'm sorry, sine cosine squared. All over cosine, right? And now you have a common denominator, but even better, you have a greatest common factor here, right? You have a sine in each of them, and you have a cosine in each of them. You could. It's not wrong to do that. If you take the sine out and then add them together, you have sine squared plus cosine squared over cosine, which is just sine over cosine, which is just tan, right? Nope. Sine cubed plus sine x cosine squared. Those aren't like terms. You can't add them together. I'm sorry, what? What is it? Right. Yeah, because of the addition. Megan? Correct. Right, like if I distributed this back through it, multiplied each of them, which is what we have over here. Sure. They cannot. No, because of the addition, yes. Like, this is not incorrect, what you have here. I mean, you have a lot of cleaning up to do at this point, but it's not incorrect. So that is okay at that point, Julia. What I would do from here, I guess I would just write everything in terms of sines and cosines and see what happened. I guess is probably what I would do, and you'd end up with it gets messy. Yeah. Yeah, it gets messy, but it's doable, and it'll eventually all cancel down to just tangent. But it's kind of a long route. But again, that's the idea with providing you like 5 questions and choose 3 of them, is if you get into something like this and it's like, probably this is okay what I'm doing, but I don't like the way it's going, and maybe you just skip and try something else. With the idea that, like, well, I can come back to this and maybe still sort this out, but there must have been an easier way to do it, but I didn't see what that was in the beginning, so. Does that help at all, Julia?
Yeah.
Okay. So that's some simplifying examples, and I think in reality, like, I tried to pick simplifying ones that were, again, like, if you did it in a good order, you would, like, could do it in 3 steps or less. I tried to pick everything, so if you start doing 4, 5, 6 steps, doesn't mean that you're doing anything wrong, but it might mean there's a better way to do it. So I tried to pick things that were not going to be like, 100 steps to kind of finish something up. I tried to pick things that would be, I think, pretty realistic. So let's do some verifying stuff now. And I think the verifying stuff is actually, in a sense, easier, because you know what the answer is supposed to be that you're shooting it for, in a way that you don't necessarily for the simplifying ones. Although, I don't want to say for sure, but I'm pretty sure the simplifying ones I picked all simplify down to a single trig function. So there's no, like, weird expressions in there. But I think that they all simplify down to nice, neat things. So take a few minutes and try to work through this verifying one. Sure. That's a fine first step. think that's what's screwing everything up. Yeah, and then why is there still a sign here on the cosine? Yeah, so I think you just got a little messy, and everything is fine though. Okay, so hopefully when you did this, you said the left-hand side looks like the more complicated one. As Gabriella had suggested, maybe we start by distributing the sine x to that quantity. So that all looks good. And then the next thing I would do is just rewrite everything in terms of sines and cosines, since my answer is in sines and cosines. And those cancel. And those cancel. And then sine squared times sine, or sine times sine is sine squared. And I have exactly what I need. So again, what was that? 3 steps, right? So, yes? Where, which step, which line are you talking about here?
So like after I didn't distribute the sine, I just wrote everything in terms of sine and cosine.
That's fine.
And then I cancel out the cosine and sine, and then it's just sine times cosine, right?
I think you would have sine plus what?
I did it that way. If you want to
Okay, so I wrote everything in terms of sine and cosine.
Why? What are you? How are you canceling these things? There's addition symbol, not multiplication.
Okay,
So this stuff can't cancel with that stuff because it's not being multiplied
so what
together.
would I do from there?
You could cancel this cosine with that cosine.
Okay.
That's okay to do, and then you distribute the sign.
Okay.
But you can't cancel across an addition symbol. Okay, let's do. There's many different routes you could take to get to the correct answer, certainly on many of these. Again, I'm just presenting what I think is often the quickest or the most intuitive route, but doesn't necessarily mean that there's only one way to do these sorts of things. And on the test, I will certainly, like if you've done it correctly and there's no mistakes, and you get to where you're supposed to get to, I don't care how you get there, provided I can understand how you got there, right? Like it has to make sense. Okay. If we looked at this one, hopefully, I think probably should have picked this side to work on. And hopefully you notice that 1 plus tangent squared is secant squared. And secant squared times secant squared is secant to the 4th. And you're done. Not so bad. Could you have started on the other side also? Yeah, you could have just written it as secant squared times secant squared and then done 1 plus tangent squared in for one of them. That's fine as well. Really no difference. Again, I'm trying to pick things that are of similar difficulty to the things that I picked for the quiz here. That is just for sine and cosine. fact, Gabrielle, it's secant squared times cosecant squared.
Yeah, no. I didn't know.
Oh. Yeah, I just checked it right there on the board. All right, so let's try this one. Hopefully you decided to try to work on the left-hand side here. First thing I notice is 1 over tangent is just cotangent. And then I'm out of good identities to use, so I'm just going to write this in terms of sines and cosines. And then we'll make a common denominator here. So when I do that, I have, oops, what am I doing wrong here? They should be the other sides, right? This one gets the cosine over cosine. And this one gets the sine over sine. So that's going to give me cosine squared plus sine squared over sine times cosine, which hopefully recognizes 1 over sine times 1 over cosine, which is just cosecant times secant. Sure, Julia. Sure. So let's do that. Yeah, absolutely. So let's start at this step. And you said you wanted to rewrite this in terms of secants and cosecants? Okay, so cotangent is, what is the identity for cotangent? Cosecant over secant. And this is then secant over cosecant. And we'll make a common denominator now. And when I do that, I get cosecant squared plus secant squared over cosecant times secant. And now this gets kind of yucky from here. This was the question Gabby asked during, was, is this just equal to 1? It's not, but what I did is I showed that it's equal to secant squared times cosecant squared using that steps up there. So you have all of those steps now intermediate. That's correct. As surprising as that result seems, that is true. And again, the steps are up here in the red box that I did for Gabby on how I'm getting that. I'd expect you to write all those steps. Yes. Whether on the side in a sidebar to just say like, hey, I know that this is equal to this because, and then write out the steps on how you knew that, or showing like embedding it into the problem, doesn't matter to me. But yes, that's not a common identity that we've established that we can use without justification. So that would be something I'd expect to see those steps for. Yes, that's fine. If it's just an immediate, like, yeah, if all you're doing is taking an identity that we have and just like adding or subtracting things to both sides, certainly that's okay. But like this thing is, like that required several steps up here to do, right? That wasn't just rearranging something we already had to get to that. That was something very different. Okay. So everybody okay with what to expect tomorrow?